Fractions. Fraction means a part of a whole region, collection, or a number. It shows a part of a whole region. Here, 1/3 part of the region is shaded. It shows a part of a whole collection. Here, 3/8 part of the collection is shaded. To find a part or fraction of a number, we divide the number by the denominator. Example 1. A. 1/2 of 12. B. 1/7 of 28. Solution. A. 1/2 of 12 is equal to 6. B. 1/7 of 28 is equal to 4. Equivalent fractions. Look at these strips. Some part of each strip has been shaded. Find out what is common thing among these. 1/2 is shaded. 2/4 is shaded. 3/6 is shaded. 4/8 is shaded. 5/10 is shaded. Clearly, all these strips have equal shaded portions. So, the fractions represented by the shaded portions of the above strips are equal. Thus, 1/2 is equal to 2/4 is equal to 3/6 is equal to 4/8 is equal to 5/10 and so on. These are equivalent fractions. Fractions that represent the same portion are called equivalent fractions. B. Look at these bananas. We can say that there are 15 bananas or 3 bunches of 5 bananas each. 10/15 of these bananas are shaded, or 2/3 of the bunches of bananas are shaded. 10/15 and 2/3 refer to the same number of bananas. So, they are equivalent fractions. Finding out equivalent fractions. Let us learn how to find out a fraction equivalent to a given fraction. To get a fraction equivalent to a given fraction, we multiply or divide the numerator and denominator of the given fraction by the same non-zero number. Example 2. Find out 4 fractions equivalent to 3/5. Solution. The given fraction is 3/5. 3/5 is equal to 3 multiplied by 2 divided by 5 multiplied by 2 is equal to 3 multiplied by 3 divided by 5 multiplied by 3 is equal to 3 multiplied by 4 divided by 5 multiplied by 4 is equal to 3 multiplied by 5 divided by 5 multiplied by 5. Hence, 3/5 is equal to 6/10 is equal to 9/15 is equal to 12/20 is equal to 15/25. Example 3. Write 5 fractions equivalent to 1/7. Solution. The given fraction is 1/7. 1/7 is equal to 1 multiplied by 2 divided by 7 multiplied by 2 is equal to 1 multiplied by 3 divided by 7 multiplied by 3 is equal to 1 multiplied by 4 divided by 7 multiplied by 4 is equal to 1 multiplied by 5 divided by 7 multiplied by 5 is equal to 1 multiplied by 6 divided by 7 multiplied by 6. 1/7 is equal to 2/14 is equal to 3/21 is equal to 4/28 is equal to 5/35 is equal to 6/42. Finding out equivalent fraction with given numerator or denominator. Example 4. A. Write an equivalent fraction of 1/3 with numerator 7. B. Write an equivalent fraction of 3 by 4 with denominator 20. Solution: A. Let 1 by 3 is equal to 7 by. Here we have to find out the missing numeral. To get 7 in the numerator, we multiply 1 by 7. Further, we also multiply the denominator by 7. 1 by 3 is equal to 1 multiplied by 7 divided by 3 multiplied by 7 is equal to 7 divided by 21. Hence, 1 by 3 and 7 by 21 are equivalent fractions. B. Let 3 by 4 is equal to dash by 20. Here we have to find out the missing numeral. In order to get 20 in the denominator, we multiply 4 by 5. Further, we also multiply the numerator by 5. 3 by 4 is equal to 3 multiplied by 5 divided by 4 multiplied by 5 is equal to 15 by 20. Hence, 3 by 4 and 15 by 20 are equivalent fractions. Example 5. A. Find out an equivalent fraction of 45 by 75 with numerator of 3. Solution: Let 45 by 75 is equal to 3 by dash. Here we have to find out the missing numeral. In order to get 3 in the numerator, we divide 45 by 15. We also divide the denominator by 15. 45 by 75 is equal to 45 divided by 15 by 75 divided by 15 is equal to 3 by 5. Hence, 45 by 75 and 3 by 5 are equivalent fractions. B. Let 25 by 30 is equal to dash by 6. To get 6 in the denominator, divide 30 by 5. Also divide by 25 by 5. 25 by 30 is equal to 25 divided by 5 by 30 divided by 5 is equal to 5 by 6. Hence, 25 by 30 and 5 by 6 are equivalent fractions. To test whether two given fractions are equivalent or not, let us consider two equivalent fractions, 2 by 3 and 6 by 9. Now multiply the numerator of the first fraction by the denominator of the second fraction, and then multiply the denominator of the first fraction by the numerator of the second fraction. 2 multiplied by 9 is equal to 18. 3 multiplied by 6 is equal to 18. We find that the two cross products are equal. So we may conclude that two fractions are equivalent if the cross products are equal. So we have numerator of first multiplied by denominator of second is equal to denominator of first multiplied by numerator of second. We shall understand this concept clearly from the following examples. Example 6. Are the following fractions equivalent? A. 35 by 4 and 21 by 28. B. 7 by 9 and 70 by 63. Solution: A. Cross multiplying we get. Here 3 multiplied by 28 is equal to 84 and 4 multiplied by 21 is equal to 84. Thus, the cross products are equal. Hence, 3 by 4 and 21 by 28 are equivalent fractions. B. Cross multiplying we get 7 multiplied by 63 is equal to 441 and 9 multiplied by 70 is equal to 630. Therefore, 7 multiplied by 63 is not equal to 9 multiplied by 70. That is, the two cross products are not equal. Hence, 7 by 9 and 70 by 63 are not equivalent fractions. Comparing fractions with same numerator. Take 4 pieces of rope of the same length. Using chalk, divide them into 2, 3 and 4 parts, respectively, and paint one part from each. We will see that the painted parts represent 1 by 2, 1 by 3, 1 by 4 and 1 by 5 respectively as shown. On comparing the painted parts of the ropes, we can see clearly that 1 by 2 is greater than 1 by 3. 1 by 3 is greater than 1 by 4. 1 by 4 is greater than 1 by 5. Or 1 by 5 is smaller than 1 by 4. 1 by 4 is smaller than 1 by 3. 1 by 3 is smaller than 1 by 2. Thus, we conclude that out of the two fractions with the same numerator, the one having the smaller denominator is greater than the other. So, if we are given a set of fractions with the same numerator, then we arrange them in the ascending or descending order according to the descending or ascending order of the denominators. Example 11. Put signs greater than or smaller than in the following. A. 2 by 7 and 2 by 3. B. 5 by 7, 5 by 9. Solution. The given fractions 2 by 7 and 2 by 3 have the same numerator. The fraction with larger denominator is smaller than the other. As 7 is greater than 3, we have 2 by 7 lesser than 2 by 3. Therefore, 2 by 7 is smaller than 2 by 3. B. The given fractions 5 by 7 and 5 by 9 have the same numerator. The fraction with smaller denominator is larger than the other. As 7 is lesser than 9, we have 5 by 7 smaller than 5 by 9. Example 12. Arrange the following fractions in the ascending order. Solution. 5 by 14, 5 by 7, 5 by 9, 5 by 3, 5 by 10. The given fractions have the same numerator. The fraction with larger denominator is smaller than the others. As 14 is greater than 13, 13 is greater than 10, 10 is greater than 9, and 9 is greater than 7, we have 5 by 14 smaller than 5 by 13, 5 by 13 smaller than 5 by 10, 5 by 10 smaller than 5 by 9, 5 by 9 smaller than 5 by 7. Hence, given fractions in ascending order are 5 by 14, 5 by 13, 5 by 10, 5 by 9, 5 by 7. Example 13. Arrange the following fractions in the descending order. 4 by 6, 4 by 11, 4 by 8, 4 by 5, 4 by 13. Solution. The given fractions have the same numerator. The fraction with smaller denominator is greater than the other. 5 is smaller than 6. 6 is smaller than 8. 8 is smaller than 11 and 11 is smaller than 13. We have 4 by 5 greater than 4 by 6, 4 by 6 greater than 4 by 8, 4 by 8 greater than 4 by 11 and 4 by 11 greater than 4 by 13. Hence, the descending order of the following fractions is 4 by 5, 4 by 6, 4 by 8, 4 by 11, 4 by 13. Like and unlike fractions. When two or more than two fractions have the same denominator, they are called like. For example, 3 by 8, 1 by 8, 5 by 8, 6 by 8, 4 by 8, etc. are all when two or more than two fractions have different denominators. They are called unlike fractions. For example, 3 by 4, 2 by 9, 3 by 7, 2 by 5, etc. Addition of like fractions. Amit and Sumit ordered for a pizza in a restaurant. The pizza was divided into 8 pieces. Amit ate its 2 pieces. This means he ate 2 by 8 of the pizza. Sumit ate 3 pieces. This means what fraction of the whole pizza did they eat altogether? They ate 2 by 8 plus 3 by 8 is equal to 5 by 8 of the whole. So, when we add like fractions, we add the numerators. We write the sum over the same denominator. Subtraction of like fractions. Let us consider the aforementioned example once again. Amit ate 2 by 8. Who ate more? As 3 by 8 is a larger number, we can say that Sumit ate more. How much more did Sumit eat than Amit? Here we need to subtract Amit's part from Sumit's part. That is 3 by 8 minus 2 by 8 is equal to 1 by 8. From the picture, you can tell that Sumit ate one more piece. So when we subtract like fractions, we subtract the numerators. We write the difference over the same. Let us understand the concepts with the help of following example 14. Solution. Add 3 by 9 and 4 by 9. 3 by 9 plus 4 by 9. 3 plus 4 divided by 9 is equal. Example 15. Add 3 by 5 and 2 by 5. Solution. 3 by 5 plus 2 by 5. 3 plus 2 by 5 is equal to 5 by 5. Subtract 4 by 9 from 7 by 9. Solution. 7 by 9 minus 4 by 9. 7 minus 4 by 9 is equal to 3 by 9 is example 17. Subtract 4 by 7 from 4 by 7. 4 by 7 minus 4 by 7. 4 minus 4 by 7 is equal to 0 by 7 is equal to. Example 18. Anuja ate 3 by 10 part of a cake in the morning and 4 by 10th part of the same cake in the evening. How much part did she eat of the whole cake? Solution. The part of the cake Anuja ate in the morning is equal to 3 by 10. The part of the cake she ate altogether is equal to 3 by 10 plus 4 by 10 is equal to 7 by 10. Example 19. Mr. Ghosh drove 7 by 9 of the distance and Mrs. Ghosh drove 2 by 9 of the distance. Who drove more than and by how much? Solution. The distance Mr. Ghosh drove is equal to 7 by 9. The distance Mrs. Ghosh drove is equal to 2 by 9. Difference in distance they drove is equal to 7 by 9 minus 2 by 9. 7 minus 2 by 9 is equal to 5 by 9. Proper and improper fractions. Proper fraction. Proper fraction is a part of the whole. Till now, we have studied proper fractions. 3 by 5, 4 by 7, 9 by 13, etc. are all proper fractions. Fraction which has the numerator less than the denominator is a proper fraction. Improper fraction. What is an improper fraction? Let us understand it with the help of following example. There are 5 family members in Gupta's family. Each person drinks half a glass of milk. To show 5 halves, we would write 5 by 2. 5 number of parts consumed. 2 number of equal parts of each glass. Here 5 by 2 is an improper fraction. 7 by 2, 9 by 5, 11 by 4, etc. are some other examples of improper fractions. A fraction which has the numerator greater than or equal to the denominator is called improper fractions. Improper fractions can also be expressed as mixed numbers. Mrs. Gupta has baked 2 cakes for her family. She cuts each cake into 2 parts. Her family eats 3 pieces of cakes or 3 halves. We can say that the family has eaten 3 by 2 or 1 by 2 cakes.